Hello and welcome to Maths on the Move, the podcast from plus.maths.org. I'm Marianne Freiberger. There are many things we learned during the COVID-19 pandemic. One of them was how useful and actually essential mathematics and in particular mathematical modeling is in order to understand a pandemic or epidemic and to get a sense of how it might develop. And another thing was just how important our behavior, human behavior, is in all of this, because of course infectious diseases spread through social contacts. One thing that became clear to mathematical modelers during the pandemic is that it would be extremely useful if we could better take account of human behavior in mathematical models. So they reflect our social patterns and the way we move around and things like that, which to some extent they already did, but so that they can also reflect how human behavior changes, for example, when the government says there is a lockdown or imposes other interventions, or just in response to our own sense of how the epidemic might be going, whether it's getting worse or perhaps getting better. To look at the question of how human behavior could best be modeled mathematically so that it gives useful information, for example, for government to make decisions, there was a workshop back in June at the University of Warwick called Mathematical Modeling of Behavior to Inform Policy for Societal Challenges. My colleague Rachel Thomas went along to some of the talks of the workshop, and afterwards she spoke to two of the organisers, Kirsty Bolton, who is an assistant professor at the School of Mathematical Sciences at the University of Nottingham, and Ed Hill, who is a Warwick Zeeman Lecturer at the University of Warwick. Rachel started off by asking Kirsty why it is important to model human behaviour.
So one reason that modelling is important is it forces us to formalise our assumptions and be really clear, sort of using mathematics and statistics, what we are assuming about the particular system we're modelling, and then again using the mathematics and statistics to explore what the consequences are of those assumptions. And sometimes in the process of formalising these assumptions to construct the model, this can help us think of processes that we might be missing that could be important in the model. So we often use modelling to understand what has happened. And in fact, we often even need models to understand what's happening now, even if we have current data. This is often about what's happened in the past. And so we need to build a model to understand what's happening now. For example, during COVID, all of our data streams on infections, hospitalizations, and deaths were about things that happened in the past. And we needed to construct, in this case, an epidemic model to figure out what we think is happening now, how many people will be infected now, how many people will be in hospital today. So that's just a little bit about why we model and what their purpose are. And I'll let Ed follow on from here.
I think it's really interesting, this thing you said about the actual process of modelling really gives you clarity of understanding the problem, what the assumptions are, and particularly that idea of it's only once you've built models that it helps you understand maybe what you haven't considered. It's a really interesting, the kind of insight even the process gives you, let alone the results of the process. Ed, you were going to follow on?
Strongly agree with what you just mentioned, Rachel. And another further use of modelling is to investigate what-if scenarios. So this can allow us to explore the potential impacts of, say, interventions. So we can get a range of possible outcomes given the available data that we have and the model assumptions. And the decision makers can take on board this information and information from other analyses, such as observational studies, experimental studies, as well as these modelling studies. And they can use all these can contribute to making then judgments and taking appropriate actions. Models can also be used to make predictions, but that's much more challenging than explaining what has happened or what is currently happening, especially in the case where human behavior is involved. And that lends itself to the motivation behind ultimately this workshop that we ran and investigating this area more about modeling behavior. And so we have some more examples to expand on within that space.
Yeah, so I mean, we both model epidemic processes, but we sort of came to realize that there are many other disciplines within applied mathematics that model systems where human choice influences some of the process that are occurring. So for example, in disease transmission, in the human context, one of the main behaviors is social contact. But of course, there are also diseases in animals and plants, and there are other behaviors that are important, like the uptake of certain interventions, like, for example, vaccination of animals. In applied sort of ecological modelling, there are important behaviours about land use and farming and reporting of disease and pests and weeds. And then another example that we think might be key is energy system use, where things like transport, lifestyle, and uptake of new technologies all contribute to how much energy we use. So all of these systems are really quite sensitive to how people are behaving. And it's likely that there's also some behavioural feedback. For example, people may be behaving in a way that depends on the state of the model system. So, for example, people may change their social contact depending on the epidemic. And then this feeds then back into the process that you're trying to model. So that realization highlights how important it is to capture behavior within these models, because if you don't do that, you could really get your predictions or even your explanations for what has happened. They could be strongly biased if you haven't considered human behavior. And this would really limit how useful they are then for policy, of course, as well as just our scientific understanding of what's happening.
So I have a bit of a sense from past work with you and your colleagues how you might model things that I can put numerical values on, like how many people are infected or how many people are in hospital, and I can but I don't have any sense how you model sort of behavior. What kind of, when you're trying to capture human behavior, are you trying to capture sort of actions like how many vaccinations? What sort of ways are there to capture human behavior in a model like this?
So thanks for the question, Rachel, and might link this into perhaps both Kirsty and mine's previous experience being contributing to the modelling response towards the COVID-19 pandemic. And that's really a key motivating example showing the impact of behaviour on infectious disease dynamics. And in modelling terms, typically those models did not include or do not include behaviour or if they do, they impose this behavioural change as some external input onto the model. So for example, Google mobility data basically tells the model how people might change the rate they visit certain settings, rather than there being an internal process within the model where behavior is updating itself. So in terms of, one aspect of behavior is potentially to do with where are you going, who are you visiting, how long for. And again, modeling terms, we can't predict how people will necessarily respond to an outbreak, or when a policy is introduced, how everyone will respond to that. Intention can be different to action. So in terms of data, you might do surveys to say, if this event were to occur, if this type of intervention was available, would you use it or not? And then you get a response to that. So you might get information about what people say they will do, their intention, but in the event actually occurs, what do they actually do? You can get a difference between intention and the action, which needs to be forced out then in terms of the modelling. And again, with the COVID-19 pandemic, there's also a voluntary response. So there might be actions people take prior to any policy being made. So for example, Omicron variant emerging, there seems to be a voluntary reduction in activity around that. So the role of different influences on behavioural choice, it's still unclear what extent they're driven by different sources of information, people, your family, online sources, public health bodies. And these are things we need to try to better understand to ultimately get a better handle on predicting the extent to which behavioural change may occur, given something occurring or a policy decision being made.
So what are the main sort of challenges and open questions in the area of modelling behaviour?
So one of the challenges is just trying to figure out what is already known, because obviously there are lots of disciplines that focus on understanding human behaviour, including anthropology, sociology, economics, psychology, and they all have their own knowledge base and approach to constructing knowledge about behaviour. So one of the challenges is just, how do we draw on all of this knowledge base, and how do we draw on it in a way that we can input into mathematical models? Ed, I don't know if you want to expand on that. Or...
Just to add that, coming from our perspectives, from the mathematical sciences side, and it can be surprising how, from our background, the training we've had, to engage with these other fields, to actually onboard their knowledge, to be able to interpret their theories, to then make use of, to enhance the modeling that we're doing. It's not trivial, and it's quite, yeah, it really can be surprising, where it's, oh, you might be talking about a very similar concept, but the language being used around in one discipline to another is just totally different. So you don't realize you're actually talking about the same thing until you can get in a room together and really get into a more extensive discussion about it.
So what is it like working across these disciplinary boundaries? I mean, how do you make those connections? What is it like interacting with them? Sort of what's your experience been working with people from other disciplines?
So it's certainly interesting and rewarding. There's lots of chance to work on new topics, and I guess to work in this space you really have to enjoy trying to understand new disciplines, and that is part of the challenge and what's enjoyable about it. I think there's lots of chance to be creative, because obviously some of these behaviours haven't been incorporated into models before, and so there's a chance to do something quite new and different. But as Ed said, there are a lot of challenges because you don't have the same knowledge base. You're used to approaching research potentially in quite different ways, and often you don't. And it's difficult. It takes time to build up a limitation as well of what other disciplines can and can't do, where their challenges lie, I guess, and where the sweet spot is for where you both may be able to make some progress. So you spend a lot of time in this team building phase where you're trying to understand each other's fields and find some common goals.
I think it's really important that we try to take learnings from other settings where they've been trying to make or embrace interdisciplinary approaches, working across different sectors, bringing in expertise from different people from different training and backgrounds. And so one example here is the One Health approach, and this is thinking about how the health of humans, domestic wild animals, plants, and the wider environment, they're all really actually closely linked and depend on one another. And the One Health idea is, instead of treating these in a siloed way, in each of these elements independently, it's actually using an integrated, unified approach that ultimately is looking to balance and optimize health across all people, animals, and the environments. And that requires having collaboration from the different sectors and disciplines. And so it's linked to infectious disease, because it's thinking about how can we perhaps lessen the risk of a new pathogen emerging, but also it's to help tackle challenges related to, say, food security or antimicrobial resistance, and generally just improve health and well-being. And this is something that can be applied. It's a concept that can be used not only at, say, international level, so directed from, say, World Health Organization, the Food and Agriculture Organization, etc., but national level, regional level, really, or even really localized community levels. But the idea fundamentally is the same, where it requires having that shared perspective, people wanting to engage, having strong communication across the different contributors, and then ultimately it's getting an understanding of the cumulative benefits, potential trade-offs that you're trying to make, given that there are multiple aspects that you're trying to account for. But ultimately, it's taking this unified approach is hopefully going to lead to more beneficial outcomes than everyone. Just if we focus purely on just public health and focus purely on veterinary health, focus purely on plant health. And because this is a type of idea that is being used where possible already. I think thinking about modeling behavior and working in disciplinary, we can hopefully take lessons from these other types of initiatives that are already happening.
What are some of the other open questions or challenges in the area of modeling behavior?
So one of the challenges is it's unclear whether we even have the correct data to test and develop behavioral models. And of course, the data stream that you need is potentially highly application dependent because, you know, there's so many different types of behavior that may be relevant. So the reason that the data question is challenging is we know that there's lots of data collected on our behavior day to day in terms of websites that we visit, transactions that we make, but a lot of this data is held in the commercial space and isn't available for researchers to use. And where behavioral scientists have collected data, there's kind of a recognized bias in the types of populations that they've studied. So it tends to have been focused on Western educated, industrial rich and democratic populations. So it's quite difficult to construct representative data sets in which people are willing to share information about how their behavior and then how they're behaving. And you know, often ideally we might like some real-time data streams that we could then use to test the predictive power of our models. But you know, these data sets are hard to come by and might be costly to construct and difficult, and also again perhaps require different interdisciplinary teams to get that right. So that, you know, raises questions about how do we sustain these interdisciplinary collaborations where you've got people to generate data sets, you've got modelers to make predictions and test those models but behavioral science as well to figure out, well, what is the emerging behavioral science from this model, let alone then how do we translate that into a mathematical model, for example, for an epidemic system or energy use. So there are certainly lots of challenges, and data is one of them, and the other I would say is sustaining the interdisciplinary collaborations.
And to add to that, ahead of the workshop, we invited the participants to share what they thought the key challenges were within modeling behavior, and as well as data and effective interdisciplinary working. I'd like to highlight, I think, 5 other blocks of areas that careful attention needs to be given. So one is related to funding and capacity, so that's related to personnel and retention of people to be able to undertake the work, and the training and interdisciplinary methods as well, thinking about they are going to be working ideally with people who have very different skill sets, and thought being given to the training being given to early career researchers to help maximize their potential and the work that is done in this area. Second is about the behavioral theory itself. So our existing behavioral science theories applicable to the context that we're particularly interested in, or does novel behavioral science theory need to be developed? A third is then model selection and parameterization. So given the data that is available, what is the most relevant type of model to use? What's the most effective methodology to get the parameter values given what could be very limited data available? Fourth is scientific communication. So given the findings, thinking about how do we convey this to different audiences, including the general public. Because we're talking about behavior, it's possible we can get this aspect of, if the public are looking at modeling results that could impact their behavior, which could then impact the infectious disease dynamics, etc. And well, this could be applicable also to energy use and other settings. And the last challenge to comment upon is, and linked to that last point, is about ethics, and that's linked to, if you're trying to enhance our understanding about behavior, is what are the relevant data collection methods? If the model results are being looked at that can impact people's behaviour itself. So there are potential ethical questions that need to be thought about in this space.
I think the ethics side is probably something that like I don't think I would have thought of that before sort of the conversation with you. But yeah, of course, if you're modelling people's behaviour and then potentially the work is affecting people's behaviour, and then I suppose privacy things to do with data collection, it's a really interesting, it's an area that brings in so many interesting aspects to it, isn't it? So what were sort of some of the highlights then of last week's event, Ed? What were some of your highlights?
So I would say the amount of dedicated time there was for both the formal and informal discussion, and having that helping us identify common goals and challenges, and the vision would be using this as then a way to create a community that then collectively is looking forward to tackle problems related to mathematical modelling of behaviour. And Kirsty, what were your own highlights?
So I think the workshop was great for showcasing the broad interest in this challenge of modelling behaviour. So we had various sectors represented. We had people from government agencies, people from private consultancies, and multiple academic institutions. And then, of course, from within academia, we had behavioural scientists, data scientists, sociologists, mathematical modelers. So it's quite exciting to see that the number and type of different sectors and people who are interested in this, which gives you hope for kind of that there is scope to make progress in this. So a number of the participants were people who'd already engaging with the Juniper partnership and epidemic modelling, but it was much broader than that as well. So we had a mixture of invited speakers. It was a really interesting range of talks from, I think it was sort of evolutionary anthropology, talking about how cultures evolved, to like the mafia, modelling the mafia in Nottingham. There was a really wide range of different talks, and we had speakers from a range of career stages, and we in particular had this block of 5-minute talks where early careers could get involved, and then they were invited to the further discussions, which helped really get a range of perspectives.
That was Kirsty Bolton talking about some of the amazing talks that happened at the workshop in June at the University of Warwick. There are further plans in the pipeline to build on the workshop that happened in Warwick. One of them is that Ed Hill is currently guest editor of a special issue on behavioral epidemiology, which is to appear in the Journal of Mathematics in Medical and Life Sciences. And the idea of the special issue is to get together a set of work to improve behavioral realism in methods addressing problems in epidemiology that are impacted by human behavior. And there's another international workshop being planned by Ed and Kirsty and their colleagues. It's going to be a satellite workshop of the Isaac Newton Institute in Cambridge, and it's probably going to happen in 2026, looking at some dedicated challenges of how human behavior might best be modeled mathematically. To find out more about epidemiology and about the work of the Juniper Partnership of Disease Modelers, go to plus.maths.org/Juniper. Thanks for listening, and bye for now.